Hey guys, Mr. Lloyd here, going to work with you on Monday, April 1st work. This is page 1 of 3 here. Let me just do a quick little zoom in so we can start at the top here. And I'll just show you how I solve these problems. So number 1 gives us a partially completed rate table. And our job, first thing we need to do is circle the unit rate. That's the amount of, or the distance per unit time. That's per 1 second. So that's, you're circling here the unit rate 1 second. This person travels, or this thing travels 2 yards. And then we use that unit rate to fill in the rest of the table. So if we're given that it went 10 yards, we know that it would take 5 seconds. If we're given that 3 seconds passed by, we know that it would have traveled 6 yards. If we were given that it had traveled for 2 seconds, then it would have traveled 4 yards. And if it would have traveled 8 yards, then we know it would be 4 seconds. And then we graph this, and what we do with the graph is we use our knowledge about these tables, where we know that the left column here, this column here, is our x values, seconds, and the graph helpfully labels that for us. And the right-hand column here is our y value, it's yards. So for my first plot, I'm going to go over 1 for seconds and up to 2, and that's where my dot goes. My next plot will be 2, 4, and so I go over 2, or to the right 2, and up 1, 2, 3, 4 to that dot, and so on and so forth. And we just graph the rest of these points. And our last one, our highest value was 5 seconds. It went 10 yards. And I do the dotted line there because that data is not given to us, but we can make a reasonable inference that the trend would continue if this graph was bigger. That's not super important, but just so you know why I did the dotted lines there. All right, so circle each ratio table. Here we're just looking at these 4 ratio tables, A, B, C, and D, and in this case there's only 2 of them that are actually ratio tables. Ratio tables, remember, let's look at B first. So B, the column on the left, excuse me, the left side here, this is the values of 2 in the multiplication table. Here on the right side, these are the values of 3, so the ratio is 2 to 3, and they track down. If you go 3 times 1, 2 times 1 and 3 times 1 is there, times 2 is here, times 3 is here, times 4, and finally times 5. And C is the same thing with the ratio, the initial ratio of 4 to 9, and this all tracks down, just like the multiplication tables. Here in A, the reason I did not circle this is we go 3 times 1 is 3, times 2 is 6, times 3 is 9, but here we're missing a 3 times 4 value, so we're missing that 12. 20 works, but we're missing the 12, so that is not a ratio table. That's a nice data table, but not a ratio table. And here we have 2, 2, 3, 4, 5. That is not a trend that we see in the multiplication table, so that should be a dead giveaway right there. All right, so number 3 asks us to use a factor puzzle. It tells us that we have a mixture. We're doing one of those color mixtures, so we've got 8 cans of red paint and 14 cans of white paint. And so, I just switched my view. That's kind of interesting. All right, anyway, 8 cans of red, and so I set it up just like this. On these lines, I just write my initial ratio, 8 to 14, and I fill in the values in my table, 8 over here, 14 here, and then I look and I say, well, 8 and 14, those are both multiples of 2, so 2 is my factor, that's why I write it out here. 2 times 7 is 14, 2 times 4 is 8, so that's where I got the 4 and the 7. And then 7 times 4 is 28, and 4 times 4 is 16. And so 16 was our question, how many cans of red did we need, or excuse me, of white did we need? Did I do that correctly? Let's see here. She has 20 more cans of red paint. How many cans of white paint does she need? I might have messed this one up. Guys, I'm going to say that number 3, I'm throwing it out. This one might have been a goof up on my part. It looks like I put the 20 in the wrong column. So I made a mistake here. Number 3 is no good. Number 4, as you can see, I'm running short on time here. Number 4, we set up. Natalie and Dan both start saving their money at the same time, and they have the same rate, or they keep their own constant rates. So Dan starts out, he goes from 6 to 15, Natalie 14 to the unknown x. I set it up as cross multiplication there, and you can use mine to solve yours. Ultimately, she will have saved $35, which is $20 more.